it is most widely used mortars in industries because of rugged construction and where the characteristics of the motor can be changed with respect to torque and current. So squirrel cage type of motors having moderate starting torque and constant speed characteristics mainly preferred for driving fans, blowers, water pumps, grinders, mixers, lathe machines, printing machines, drilling machines, etc. Whereas slip ring induction motor can have high starting torque as high current as maximum torque. Hence, they are preferred for lifts, hoists, elevators, cranes, and compressors. So these are the applications of this induction motor. Next, coming to the advantages of induction motor. The first advantage is cost is low comparatively to other types of motors, and maintenance is less as robust as rugged construction. It is simple in construction, efficiency is high, power factor is better, the starting torque can be controlled in slip ring type. So the limitations are the starting torque is low and cannot be adjusted in squirrel cage. And the speed control is difficult because in squirrel cage the conductors are braced at the ends of the are the uh, at the ends using a end rings. So the various parameters like speed, power factor, efficiency vary as load conditions changes. So this cannot be used, whereas the squirrel cage induction types of motor. Now coming to the problem, if you observe here, an 8-pole alternator runs at 750 rpm and supplies power to a 6-pole induction motor which runs at 970 rpm. So what is the slip of the induction motor? See, the main concept we are discussing here is we to calculate the slip of the induction motor. So you have to just make a note of the given data of the alternator. So given data is the poles as 8 and the speed of the armature is 750 rpm and the frequency generated EMF is equal to EMF generated frequency will be equal to NP by 120 or Pn by 120. So that is Ns in the armature. So that can be calculated as 50 Hertz. So the supply frequency for the induction motor is 50 Hertz and given P is equal to 6 number of poles of the induction motor. So you can calculate the synchronous speed of the induction motor. So synchronous speed is 120 F by P. So 120 into F by P. So we have to calculate the frequency from the given data of the alternator. So we get Ns is equal to 1000 rpm. If you observe, the synchronous speed is greater than the rotor speed. So now, to concentrate on S, we need to arrive with the formula that is N is equal to Ns into 1 minus S. So we know N, we know Ns, we need to calculate the S. So S can be 0.03 or 3%. So slip is equal to 3%. So the next question here the three-phase six-pole 60 Hertz motor has a frequency of rotor current at full load of 1.8 Hertz. Find the synchronous speed and slip at full load. Okay, so we need to calculate the synchronous speed at full load. So synchronous speed is given by 120 F by P. So given frequency is 60, so we get 1200. So what is the slip now at full load? S is equal to Ns minus N by Ns. So we have a rotor current, a full load of 1.8 hertz. So Fr is equal to 1.8. So S can be calculated, S is equal to Fr by F. So you can calculate S is equal to 1.8 divided by 60. So S is So we get 1.8 divided by 60. So that is S is equal to 0.03%. That is nothing but 3%. The slip at full load is nothing but 3% because the frequency given at full load is 1.8%. So that is all concepts of problems with the applications and limitations of induction motor.